Hello. Right, we're going to talk about networks again, only this time we're going to talk about some older technology, which is the bus, the ring, and the token ring. There's a fancy word here, and that word is topology. Topology itself is approximately equal to shape. So we're looking at network shapes. Now, for reasons I'll explain, nobody really uses these network shapes anymore. You may come across them. The last time I used any of these was back in 2000. So they haven't really been used that much, but you need to know them anyway. And there's a little bit of history involved. So let's take a look at them now. So the first thing we're going to look at is, in history terms, there was an amazing guy called Nikola Tesla. So here's a picture of Nikola Tesla. He is the person that we have to thank for alternating current. He realized that the faster you alternated electricity, the more efficient it became at passing along wire. In fact, if you alternated it fast enough, you wouldn't need the wire at all. And he didn't actually need plug sockets for power in his house. He just used to carry an aerial around. But the big thing where this affects us is that when we send information across the network and we use wire, we want to get lots of information through, and that's lots of ons and offs. And that's effectively like sending through high-frequency electricity. And if you let it, it won't need wire at all. It'll try and fly through the air. And that's actually a really weird concept. But it does exist anyway. So when we look at using a single cable to transmit high-frequency data, we have to be careful about it. In fact, we have to use special connectors. And this is the kind that we used to use on networks. This is called a BNC. That's kind of like a bayonet socket, the type you get for light bulbs where you plug and twist. In the center here, you'll see a single pin. That single pin is where all the data is transmitted, and around the outside was shielding to prevent that data from basically just being transmitted into the air. So you had to shield it. This was a bit of special equipment. That plugged into the back of your computer using a special network card. Here's a picture of one here. This network card, that part there, that's the that type was called an ISA. That goes way, way back. This is a very old network card. It's pre-PCI. That plugged on the inside of your PC. This bit here stuck out the back. And there's your BNC connector. And that is what we call a T-piece. Find one of those. There's a T-piece. Again, special equipment. You had to plug everything through these kind of weird bayonet-type sockets for it to all work. The other big thing you had to do with BNC connectors is you couldn't leave any part of it exposed to the open air. Otherwise, you'd lose all signal. So it seems extraordinary, but you'd actually have to put a cap on the end of any exposed lines, which is literally, it's just a piece of metal shielding that went all the way around, so that that single wire in the middle was shielded from the outside world, totally. I worked in an internet cafe and it had this cabling running around on the wall, and people used to look down and go, "Ooh, shiny thing," and they'd try and unplug it to take it as a souvenir, at which point the entire network used to crash. And I'd wander over and say, "Please put it back." So it sounds extraordinary, but if you had that single wire in the center exposed to any of the atmosphere, it would lose signal. You may have seen similar kind of wires connected to a satellite or cable box. It's a similar principle, high-frequency data. Now, so let's get back to, that's the kind of hardware we had to use, and it's called BNC. Now, that hardware had basically was one wire, and you could connect those one wires in a very simple line, and we called that simple line a bus line. And the idea of the bus line was that you had a lot of computers all in a line, and you would take this BNC wire and you would loop it between the computers in one straight line. and then you'd put these little T pieces, those BNC T pieces, and you'd connect off from there, and you'd wire it into each computer in a nice, simple line. Now, this is called a bus, not so much because of the wheels on the bus go round and round, but think more kind of bus route. You could actually argue that, in fact, you never get on the bus route, you get on a coach or a carriage. And it's the thing that calls itself the bus is the direction it goes. So that is our bus route there. That's the bus. So you'd connect all the computers together on one single wire. You would also need to connect your hub or switch box. And, of course, you would need those fancy, funny little caps at the end, those little terminators on the end. Otherwise, you would lose signal. And this is what we call a bus network. Now, it had advantages. It was very cheap. You only had one long wire running around the room or the office or wherever. So very cheap and very quick and very simple. Those are great advantages. But as I found out, its disadvantages, it was quite fragile. All it needed was one break anywhere, and the whole system would stop working. Also, that long cable used to lose signal if you weren't careful, so some of the computers, the signal, even though it was high frequency, would fade by the time it got to the hub. So they stopped using them from then. Now, there was a variant of this, almost the same. And that was, they said, well, hang on, what we've got here is we've got a terminator there and a terminator there, and this is silly. Why don't we just take those two ends and connect them together? Then we don't need the terminators. Also, that means that all the computers theoretically have a shorter distance to get to this hub and each other. So let's have a look at that. So there was our bus. Someone had the great idea of connecting them together and put them around in a nice circle, which oddly enough happen quite often. And again, we would have now not a bus topology, a bus shape, we would have a ring shape. But effectively it's the same hardware, same BNC connectors feeding off to every computer. Just no terminators now, because there was no end to the cable. I preferred working with the ring over the bus network because you could make a gap anywhere, put a couple of terminators in, and you could isolate a computer. It's much, much easier to do that. And of course, you still needed a hub to control it all. The hub is basically like a policeman directing traffic, is it? It told the computers how they could communicate with each other, but we'll talk about that on another video. So this was a token ring. Advantages, again, very, very cheap. With the shape of it, it did lend itself to going around the outsides of walls. So if you, for example, ran a classroom type office, then that worked perfectly, but you used to have a lot of cabling looping backwards and forwards. And the distance from anyone, the computer was much, much closer. So great advantages to using it compared to a bus. It was a better technique. But both the bus and the ring suffered from one massive problem. This was just one single wire. Now, computers break the files into little packets of information. So say I had a file that computer 1, I'll call this computer 1, wanted to send to computer 2. The first thing you do is you'd break it into a small packet, and it would then transmit that packet on that single wire. And it wouldn't just go in one small thing to 2, it would fill the whole wire. That would be actually transmitted to every computer. The only thing is that it was only computer 2 that wanted to receive it. So it would transmit it across the whole wire and take up the whole wire for a minute fraction of a second. And that was all well and good. And it did it so quickly that, oddly enough, most of the time, even with all the computers transmitting little packets, the network appeared empty at their speed. Mostly there was nothing being transmitted. But then computer 3 wants to talk to computer 4. So it's also sending out lots of little packets. And then computer 4 maybe is sending a packet to computer 1. And gradually more and more of these packets happen, by which time computer 1 is now ready to send the next packet of data from its file off to computer 2. So that's now going around. Now, and it's not as if you can have a packet here. It's not like a road where you can have one packet there and one packet there, and that's fine. They don't meet. The packet was a signal. It was data. It's like, imagine you're in a room and you were calling out a number. Yep. And then somebody else, halfway through you calling out the number, started calling out their number. Yeah? It's the same thing. It was one wire, one place. So if you had two computers trying to send a packet at the same time, those two bits of data would get garbled. And that's what we call a collision. And then what would happen is both computers would have to resend out their packets of data again. And this would then mean there's more data on the network and more likely of more collisions and more data being sent, so you then have even more packets being resent because they collided and they had to be resent. And eventually the whole network would grind to a halt. And I've seen that happen a few times. It normally on this kind of network would happen at around, if you had busy traffic, probably around 20 computers would easily cause that if everyone was using the internet to listen to music, download pictures and so on and so forth. It didn't take much. And it was one company came up with a great idea. What they did was they invented a token. They said, well, hang on, let's have a token, a bit like a baton in the relay race. And what we're going to do with this token is we're going to say, well, only one person at a time is allowed to talk, only one computer. And that computer is the computer that holds the token. It's the only one allowed to send a packet out. So this computer has the token. It wants to send a packet, so it sends the packet off with the token to say 4. 4 takes that token and says, thank you very much, but you know what? At this moment, microsecond in time, I have nothing to send or say, so I'm going to pass on the token to the next computer. Computer 1 takes it, says, oh, thank you very much. I really needed that to send my next packet out. It sends the packet off. Computer 2 picks it up. It says, oh, thank you. Actually, I've got something to say, so it takes the token and sends it round again. So the token was a way of forcing each computer to take it in turns. If it didn't want to say anything, it just passed it round. Now, this was actually controlled using the hub itself. So all of this wasn't done physically. It wasn't literally going around in a physical circle. It was affected. The actual shape of your computers didn't matter. It was the numbers they had been assigned. And this was called a token ring. That meant that the advantage of this is you could have much larger networks with less chance of collisions because they all had to take it in turn. However, after a certain size, after a medium-sized network, this also used to slow down. And it still suffered from the same fragility of the bus network, as any break in it would take the whole network down in one go. So, for those reasons, sadly, we no longer use either our bus or our ring networks, or even our token ring networks. Neither of those two systems are used anymore. And in the next video, what I'm going to talk about is star networks. Okay, there should be a quiz for you to do. Please do that now. Thank you.